Guys, this is Learning to Shine the Science Kid, and this is going to be a wild and radical video. No, it's going to be called Radical. Anyway, this is a spinning top. It spins, as suggested in the name. I said spins. Anyway, so spinning tops have gone back to about ancient Greece times. This DIY top is similar to the tops that the ancient Greece kids played with, except they were more detailed and they didn't look so homemade and handmade and so weird. Also, they always worked whenever you spun them. Anyway, so let's get into the science between spinning tops. Let's talk about momentum first. Momentum is the tendency for an object to move forward in a straight line. I have a momentum going up, then down, up. Like. Anyway, so this top has angular momentum, which means the line of momentum is going that way. And I'll show you a cool experiment. If I blow on this side while it's spinning, what do you think will happen? Will it fall down to this side? Will it fall down to this side? Did I hear most people say this side? Well, let's try it out. You were right. But you see, when I blew on it softly, it moved. Nuh-uh. None of the answers were correct. It moved to this side. That's why it's a radical video. Anyway, so because the top goes. That's it. Sorry, guys. Sorry for the interruption. Anyway, so the angular momentum is when it's spinning, it goes this way. And it has rotational inertia, which means it wants to stay. And also, when I push on this side, I made it spin faster because when I push on this side, it processes around, which makes it start going like this. That's what happens when it loses speed. It processes around more because it's leaning to one side more and more, which means it has to process more to stay angularly stable. So, angular precession is due to rotational inertia to stay in the position where it was rotated at. If any of this is too complicated, my science teaching is for all ages, and I know that as a fact. So, for the youngsters out there who need a little bit more simplified information, a top spins when you add a force to the side. This force is called torque. Say it with me, torque. 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 Anyway, so when I apply torque, it spins. And as you heard me say earlier, it wants to stay in the position or place it wanted. It was pushed in. See? And procession procession, 4 syllables, is when it has a force applied, and because of the inertia, it wants to stay in the place it was pushed in. So, that's how you pronounce pushed. Pushed. But don't say it with the 2 P's. So, pushed. When it was pushed in this place. So, when you apply a force here, it doesn't just go like... It wants to stay in the place it was pushed in. So, it processes around, or spins around, so that it can stay in the place it was pushed in. So that is spinning tops explained for you. Now, I am going to put it on a slippery surface. What do you think will happen if I put it on a slippery surface? The inside of my mom's phone case. It's a slippery surface. It still stays in its place because it has a certain pattern. No, if I don't put it in the pattern, then if I lean it, it'll move. It'll process because gravity is pulling it down this way so that it can go down. So it'll move in the pattern of the phone case going down, and then it'll get influenced by gravity, the force that pulls down, where to its destination, the ground. Down to the ground, gravity. 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 Angular rotation, what makes top stay, spin. Angular momentum, what makes tops spin, what makes tops go. Angular momentum, the thing that keeps it spinning. Force, the thing that starts spinning. Angular tops, they are spinning, spin. Rotation equals stabilization. Stabilization means you are stable or stabilizing. And that was our science song for today. Now, bye guys, and keep on spinning. But first, let's watch our super scientific top here spin. See the pattern? It's moving. It's moving in the pattern of the phone. Now, bye guys. Keep on sciencing. After clip. Today, now, in this actor's clip, I will be showing you how it was made. How this wonderful, amazing top was made. So, first, okay, let's go into serious. First, to make this top, you need a toothpick, 2 bottle caps from any empty bottles you can find. But if there are half water bottles that your parents can drink, my parents love to drink half bottles that have been left out, and that you can get 2 caps from those half bottles that your parents are going to drink, or probably throw them out after you use the cups. Now, enough about half water bottles. After that, you're going to stick it to a marker. Okay, I'm just joking. After that, after you get your toothpick and your water bottles and your water bottle caps and toothpick, you are going to get some tape. Now, you might need some adult supervision for this. And I made this while breakfast, so my parents were. So my mom was there. And you're going to need some tape. Now, let your parents cut the top of the toothpick off, because you're going to be holding it like this to spin it, and you don't want to get pricked. Anyway, so poke 2 holes in each water bottle. I don't want to break this apart and make it all over again, so that's why I'm just doing stuff with it. Okay, anyway, so you're gonna poke 2 holes in the water bottles caps and stick them into the toothpick. Now, you're going to put one with the top facing up with the solid part facing down, and the other one with the solid part facing down, so that it looks like this. And then you're going to tape those together and maybe draw a few lines on them for the optical illusion. I don't have lines on mine for some reason, though I just drew some. So let me go draw some lines. So guys, I have a green marker and I'm going to draw a line on it. So for the optical, now make sure to draw the line bold, like this. I recommend a Sharpie, but a pink marker would work great. Anyway, so after that, you're basically done. Now, if you spin it, the line should disappear. Now you can see the line, right? Now it's not there. Why? Because since the top is spinning so fast, the brain can't perceive the line in one image because it's moving so fast in a circle so much. But if you spin it slow, spin it speedily, okay? So, bye guys, and enjoy your 2 experiment in 1 scientific toy. Bye. Keep on sciencing.